A Bitcoin blockchain does not have a Turing complete computer on it. It's just a ledger. It's just storage. It's an immutable ledger that never changes based on the code on it.
Technology is transforming how we think, how we lead, and how we win. From Intervision, this is Status Go, the show helping IT leaders move beyond the status quo, master their craft, and propel their IT vision.
Bitcoin, Ethereum, Litecoin, all examples of cryptocurrency. When you hear the names, do you dream of getting rich, or do you shudder having flashbacks to that ransomware attack demanding you pay the ransom in a cryptocurrency? What may not come immediately to mind is blockchain, the technology that serves as the foundation of these cryptocurrencies. It is that technology we want to dive into today, blockchain, and how it is being used in a variety of industries today, not just for a new digital currency, but solving real business problems. Our guest today is Tommy Cooksey, a blockchain architect and master trainer at SymbaChain. When Megan Schaefer, our executive producer, and I discussed digging into blockchain on Status Go, I began to reach out to my connections to find an expert we could speak with on the topic. In an odd twist of networking fate, I was teaching a class not long ago, and one of my students said, "Hey, I see on LinkedIn you're connected to Tommy Cooksey." Curious, I looked up Tommy on LinkedIn, and sure enough, we were connected. And lo and behold, he's a blockchain architect. I love it when a plan comes together. So, welcome to the show, Tommy.
Thank you very much, and I'm really happy to be here. And hopefully, I can help shed some of the light on what makes some of this technology so hard to understand.
I am really looking forward to this. This is a topic that we really haven't dove into at all on Status Go. And I think, as our listeners will find out, it's a technology that is beginning to, I wouldn't say it's reached the stage of being pervasive in business yet, but it's definitely taking hold. But before we get started on that, Tommy, I'd love to hear a little bit about your background. Would you mind sharing your journey a little bit with our listeners?
Yeah, certainly, and thanks for the opportunity to be here. So a little bit about my background. I've been working in IT since the early '90s, so that dates me a little bit. But in general, what I've been able to do is through that time, I've been various different hats, from an architect to a developer to a systems administrator, and in doing so, I've worked with cryptography quite a bit. Um, I originally got exposed to IT while I was in the United States Marine Corps, and obviously in the Marine Corps we use cryptography a lot, and I was an operations clerk, so we use cryptography a lot in order to secure our messaging. So what that afforded me the opportunity to do is have a good understanding of how mathematics was being used in order to secure data. And continuously throughout my career, I've used cryptography in order to secure information. And in 2015, about around that time, I had left the Marine Corps, and I'm a full stack PeopleSoft developer as well. And I was teaching PeopleSoft, and I was talking with my brother, who's now an electrical engineer at Lockheed Martin in Denver. And he was in high school at the time, and I was having him put a new hard drive in my laptop for me while I was at work. And so he didn't get it done, and he said the reason he didn't get it done was because he was working on his Bitcoin mining machine. And it was such an interesting conversation. And he actually introduced me to this very first concept of this thing called Bitcoin. And when I started to actually pop the hood on what he was talking about, I realized that all he had was simply a ledger that he had with a bunch of people. And he was using cryptography to prove that the information that was on that ledger was accurate and true.
Yeah.
And they put a gaming mechanism in place in order to reward the individuals that could win those games. And this was actually very early on in Bitcoin, and that was basically just proving the hash power, basically. And in essence, the gaming mechanism created truth in transactions ultimately, and that's what we see at Bitcoin.
So, first of all, let me thank you for your service as being a former Marine. You left out part of the story about how you
Sure.
got into technology in the Marines. So you got to share that.
Yeah, absolutely. It's kind of a fun story. I love telling it. And so, in high school, I could type real fast. I took WordStar and those types of classes. And lo and behold, since I could type real fast and I knew the programs to write documents, um, I was the computer guy. So they trained me up, man. They trained me on Windows NT. They trained me on all of these different things. And back in the early '90s, and again, that's about when I got out. I got out in '94. There was not a whole lot of people that had those skills, and I was in high demand. And I'll be
Yeah,
honest,
yeah.
man, being an E4 in the Marine Corps, you don't get paid a whole lot of money, and you don't get a whole lot of value add of being it rolls downhill, and that you're at the bottom of the hill at that rank. So
Yeah, yeah.
anyway, when you start to look at your skill set and the industry, I decided that maybe I should roll my dice and take my skills elsewhere, and that's what I did. And ultimately, I've been around at a lot of different companies. I've worked at a lot of the big five consulting companies, and as I mentioned before, PeopleSoft, which now is Workday, it's also PeopleSoft, which was purchased by Oracle. But the gentleman who created PeopleSoft, Dave Duffield, he is really a pioneer in a lot of our enterprise resource planning and integrating data. And so my ability to use that product and understand how you could build these big data sets and actually extract value from it, that really helped me to understand where even a bigger system like a blockchain could really come in handy, where we could start to build things into the workflow, build governance into the process instead of having to trust, right? So I like to say that at SymbaChain,
Yeah,
which is the
yeah.
company that I work for, and by the way, I skip around a lot. So I actually now work for a company called SymbaChain. Prior to that, I taught AWS Cloud, and I also am a AWS Cloud instructor. Anyway, at SymbaChain, I teach blockchain, and that's really where my passion is. And the reason my passion is there is because when the internet first came out, we wanted to have a decentralized network. We wanted to trust the data that we were receiving and sending amongst one another, but we didn't have a real good way to do that, right? And so we had to kind of patchwork this stuff together. And what we've built is we've enabled these data silos, these platforms that
Hmm.
in essence can become a powerhouse in and of themselves. I mean, the platform has deplatformed our own president. Whether you like that power or not, it's there, and that's something that we need to address. And so we
Hmm.
probably need to start looking at protocols instead
Yeah,
of
yeah.
platforms. Man, when I start to think about my ability to be a pioneer in something like that, I feel like Thomas Jefferson or something.
That's right. That's right. Tommy, I've heard a lot about Bitcoin and even a little bit about blockchain, but what
Sure.
what is it? Can you break it down? Give us a primer on what is blockchain?
Yeah. So when we think about a blockchain, the first thing that we need to do is we need to distinctively define that what we're trying to do is we're just simply creating a ledger.
Hmm.
So anytime that we have an asset, we always have a ledger. And that ledger is usually in the form of dual entry
Hmm.
accounting. So let's just go start there. So every credit has a corresponding debit, and we can track that in that dual entry accounting system. Now, with a blockchain, what we're adding is we're adding this really unique number at the end. And the importance that you need to understand about this big number is this number is so big and so unique that it's 2 to the 256. That's how big that number is. And so mathematically, that's big enough to give every grain of sand or excuse me, every atom in the universe its own address. And so it's a really, really big number. With that, we have the ability to have provenance of certain
Hmm.
things. So what we can do is we can take a set of data, take that index that I just
Hmm.
mentioned, and use that as an input to the next set of data that I'm going to stack on top of it. So now I have these blocks of
Hmm.
data, and they're chained together with this indexing mechanism. So should anything change because of hashing, the way hashing works is you take an input, and if that any even one bit changes, so if you add just a space to the input,
Hmm.
then that's going to dramatically change the output. So it will create this mechanism that will have one way and collision resistance. So ensuring that the data that you put in will always be the same, based on, you always get the same hash as long as you put that same data in. And that's the one way. No other input would be able to create that hash. That would be a collision. So that would be the collision resistance. So those two key characteristics of hashing provide the triple entry accounting. So remember, we talked about dual entry accounting.
Yeah.
So triple entry accounting is adding a hash so that now that data can't change ever. I don't have to trust the bank. I don't have to trust anybody. I just trust the math. And as long as I have my own ledger, then I'm just looking at the ledger. I can even look at, if I don't want to look at my own ledger, I could look at all the ledgers that exist. And as long as 51% of the ledgers say that thing, then that must be the truth. And so that's where Bitcoin comes in. You hear these things called 51% attacks and stuff like that.
Yep.
What that means is somebody's trying to take control of all of the ledgers that are in the network, and they have more than 51% of the network. That's a 51% attack. But that network is based on compute power.
And I guess that's where my mind goes kind of blown a little bit, because, okay, I'm thinking simple. I got a spreadsheet with rows and columns, right? And one of the columns is this hash on the end. Where does the distributed nature come in? How does that work? Because I've got my spreadsheet here. How do I know what you have on your side?
Right. And that's really a great question, because really we still don't trust each other. Even if that hash is there, what we're going to add into it is we're going to add in a gaming mechanism. So as I mentioned before, each time I change a small variable to the input, the output changes dramatically. So what if I created a game and I said that your output had to meet a certain level of hardness? And what I mean by that, since it's a really big number, it's like 2 to the 256 bit, maybe what I say is that your first character has to be a 0. And so you have to keep iterating through different variations until you can come up with that first character being a 0. Now I have a game, right? So remember when I mentioned my brother was mining?
Yeah.
Well, that's exactly what he was doing. He was building a machine that would just go through these iterations quickly, very quickly. And as soon as he could get a block hash that had so many leading zeros, then what he would do is he would just yell bingo, right? And that's what miners do in Bitcoin, is they're just basically iterating through this thing called SHA-256. That stands for Secure Hash Algorithm, 256 bit. So they're just going through numbers until they can find a number that meets the hardness requirements of the network. Currently in Bitcoin, I think that's 19 leading zeros.
Wow.
So it's kind of important. Yeah, that's kind of a really hard, right? So to understand how hard that is, that means that all of those computers that are trying to mine Bitcoin, it takes all of them 10 minutes to come up with one of these numbers that has 19 leading zeros. And as soon as they find that out, they're just going to yell bingo to the network and say, I won the game. Let's start a new game. Now, it's going to be really hard for the rest of that network to come up with their own number, but it's real easy for them to check the number that I just advertised. So all they're going to do is just check my math. Math looks good. Okay, give them their reward. Let's start a new game.
Yeah.
Now, let's talk about that for a second, because what we just did is we created a mechanism that created consensus between the ledgers. That means that as long as the individual that is holding that ledger is acting in an honorable manner and doing the things that the code says that they should do, then the data is going to be accurate. If they try to manipulate the code in any way, it's not going to reflect. And so the rest of the network it's not going to check out. And so when they go to look at the work, the proof of work is not going to be there, and they're going to decline the block. They won't add it to their ledger.
Now, we've talked in terms of debits and credits, and even the word ledger conjures up financial data, blockchain
Yes.
is more than just financial data, right? I mean, there's smart contracts, there's other use cases for that concept. Can you talk about that a little
Yes.
bit, Tommy?
That is a really great subject. So I'd like to talk a little bit a fun story. I think it's always fun for us to kind of use an analogy.
Hmm.
But when we talk about this cryptography, one of the first places that this cryptography was ever used was in World War II, and it was used by the Enigma machine. So that was the German typewriter thing that had these circuits that would send a message through Morse code through the radio waves. Because remember Marconi, who was
Hmm.
an Italian inventor, of course, part of that Axis powers. They were able to use that technology to communicate to their U-boats in the German Channel. So they used this thing called the Enigma machine, which was in essence doing this hashing mechanism that I just talked about. Well, there was a mathematician by the name of Alan Turing, and he was working at this place called Bletchley Park in England. And there was a bunch of mathematicians that were basically trying to reverse engineer this program, to reverse engineer this cryptography. They actually were not able to do that. They were not successful in reverse engineering the cryptography just with the computing mechanisms. But what they were able to do is they were able to create the very first computer. I know it's a big introduction,
Yep.
but what we have now is we have a Turing complete machine, and it relates right back to Alan Turing. And that very first computer that they built at Bletchley Park was then formalized by Professor von Neumann afterwards, and that's what we use as a computer. So
Hmm.
today, when you use a calculator or anything that is a computer, we ask, is it Turing complete? And that Turing completeness is what creates the ability for us to have smart contracts. Now, that's why I created that story, because a Bitcoin blockchain does not have a Turing complete computer on it. It's just a ledger. It's just storage.
Hmm.
It's an immutable ledger that never changes based on the code on it. Now, what we can do though is if we want to write logic, so like what Alan Turing was doing, if statements and fors and loops and all these things that you would put in your programming code to go through and do things, then you would have to write that into your coding logic,
Hmm.
and it needs to be interpreted by a machine. And so that machine, in the case of a blockchain, predominantly currently has been held by what's called the Ethereum virtual machine. So John alluded to this with smart contracts.
Hmm.
The Ethereum virtual machine is the computer that I can hand logic to in order for that computer to interpret it. Now, that computer is not just the computer running on one computer, as we just mentioned. It's lots of computers all throughout distributed within the Ethereum network.
Hmm.
So, in order for those computers not to have what we would call a denial of service attack, meaning that I create some code that's going to cause it to shut down, we have to pay for the compute. And that comes in the form of gas. So, we spend gas in order for the get them to run our logic, and that logic then interprets whatever the code is that we have in that smart contract. So what smart contracts provide us the ability to do is start to put logic together based on those immutable states of the assets that we were talking about earlier.
Gotcha.
Really, what I like to think of is I like to think of a blockchain as an asset, and I have the ability to create all state changes to that asset. So I'm not just creating who owns it and that kind of thing with my ledger, even if anything changes to it. So for instance, if that asset is a home and that home has a new roof, then that is a state change. And so that's something that I might want to put on a blockchain, and then I can accurately get a valuation of that particular property at any given time.
Yep.
So there's lots of fun things that we can do with this.
Well, let's turn our attention to use cases. A lot of our
Sure.
listeners are, you know, leaders in IT for corporations, and they may hobby a little bit with Bitcoin, or we may have some avid Bitcoiners in our audience, but for the most part they're focused on IT for companies and how it helps drive those businesses forward. So where have you seen, in your experience, where have you seen blockchain being used to solve a problem for business?
I love that question because, a little bit of history about me. I've worked at a couple different places in the blockchain industry, and currently at SymbaChain, we don't have a coin. We're not an ICO. We're a blockchain company trying to help real world businesses
Hmm.
find solutions to their pain points, right? And use the technology to do that. With that being said, let me give you a little bit of background about Simba
Hmm.
so I can kind of set the stage for what some of our projects are. We're actually born out of a DARPA grant. So if you're familiar with DARPA, it's basically the same institution that created the internet.
Hmm.
And so it's Defense Advanced Research Project Association, I think is what it stands for. But DARPA issued a request for secure messaging. And so our founder created a program called CryptoChat, which is the ability to do secure messaging with mobile devices, right? Obviously, with that gave rise to a lot of the same technology that we use in blockchain cryptography. So Dr. Ian Taylor, who is a professor at Notre Dame, along with Dr. Yark Nabrinsky and several other faculty members there at Notre Dame, saw the opportunities as well with blockchain. And Dr. Taylor is actually one of the foremost naval. So he writes papers for the Navy on advanced technology and how it can be used for the Navy. So I think he's written more papers than any professor. So he started to look at ways that we could use it in Department of Defense, and ways that we could use it for tracking and tracing things like parts, and knowing whether or not those parts are conforming, right? So is a wing or an aircraft wing a conforming part based on the pub log data that's been issued by Boeing or by its manufacturer. And so we've been able to work with some of those entities to start building out proof of concepts, to start to be able to have higher visibility and track and traceability into that supply chain. So being able to track that resource from soup to
Hmm.
nuts all the way through all of those channels, even though sometimes those channels don't necessarily want to talk to each other. Sometimes what we do is we create what we would consider a metaverse, meaning it's the data that's metadata about the data.
Hmm.
Data about data is
Uh-huh.
metadata, and we just kind of create an element for you to be able to search into that metaverse for identifying information that is going to be important for your workflow.
So, with that, can you share some, and you may not be able to share the names of the companies, and I get that, but can you
Sure.
share some of the problems that you have solved by using blockchain?
Yeah, one of our favorite projects, and you can find some really cool videos if you go to our YouTube channel for SymbaChain. There's some really cool use cases where you can kind of watch some videos, but some of the ones that we've used for sustainability and sourcing,
Hmm.
right? So what we mean by that is, where does a product come from, and what are the attributes about that product that I need to know in order to be able to track it throughout its life cycle. And then also, can I even provide value back through to that supply chain somewhere? So think about that concept for a second. But what we've been able to do with Tokes, and that's one that I can certainly talk about, and it's on our website. Tokes is a restaurant chain in Mexico, and very much like I don't know, like General Mills maybe.
Hmm.
So lots of different restaurant types. And what they wanted to do is they wanted to have sustainability into knowing from exactly what farm did this coffee come from, and how was it roasted, who roasted it, what co-op did it come from, what were all the hands that took place all the way through the delivery, what were the various attributes about that particular device that we needed to track through its life cycle. So various different variables, for instance, that we would be pulling in from an IoT device. So we could put a sensoring device in with the packaging, and things like humidity and temperature, and those things could violate the integrity of that coffee. So we can track it throughout its supply chain and make sure that everyone that touches it doesn't violate the product for the
Hmm.
farmer, right? So the farmer doesn't have some coffee that seems over roasted because, well, the driver set the truck on the side of the highway while I went and played poker for 10 hours at the casino. So we can all relate to that kind of a concept, but those are real world things that happen, and we want to try to eliminate fraud.
Hmm.
And there's a lot of that happens in a supply chain. So this is a really good tool for doing that.
Another thing that I know we talked about that will resonate with our listeners quite a bit is vaccinations, right? And the tracking and tracing of
Yeah.
that. Can you share a little bit about how blockchain would be applied in that scenario?
Yeah, so there's a lot of people that are working towards a medical passport, and we've probably seen or heard that in the news quite a bit. And so a blockchain can really help with this. Now, whether you agree or disagree with the
Hmm.
with the politics, the tooling is available to build the ability for Johnson and Johnson to issue a vaccine ID and for you to be able to claim it, and then you to be able to have provenance that you've met a certain
Hmm.
level of medical clearance, right? So in that sense, you can prove that A, you don't have the vaccine, or B, you don't have the infection and you've been tested within so many
Yeah,
hours or
yeah,
something. So those are the things that people want to be able to prove, but many times they're using fraudulent documentation, and so we want to build maybe a better system to be able to eliminate some
yeah,
of that
yeah.
fraud.
And this helps with privacy. It helps with making sure that the data doesn't get changed or that it's fraud. I mean, it takes out a lot of things. And again, to your point, it doesn't matter what side of the vaccine discussion you end up on. It's a use for making sure that the data can't be changed and it's secure. And that applies in a lot of different industries. So
Yeah.
I'm going to put you on the spot a little bit here, Tommy, on our next two questions. Question one: where do you see this going? What industry? What they may not even be thinking about it yet, but who's going to be using blockchain next to solve a problem?
I see this going in a lot of different directions, and as humans we tend to navigate towards where we can find a value that's going to be in our wallet,
Uh huh. Uh
right,
huh.
in dollars. And so we see blockchain making that impact right now. So right now we see the impact in what's called decentralized finance, or DeFi. You hear that a lot.
Hmm.
But as an example, in DeFi, I can go and deposit, so much of my Ethereum into a DeFi contract and withdraw that back in cash, and I don't have to provide anything as far as other
Hmm.
information. I just get the finance, right? I get that financial instrument fairly easily in the form of a loan. So DeFi is making a big impact on some of the services that are traditionally being provided by banks. So I think that banks are trying to figure out a way to reinvent the service offerings that they have, because a lot of the information, a lot of the mechanisms are doing a big disruption in that realm. And so probably the biggest one that really we can easily see is, you send a Western Union payment, it's $50,
Yeah.
right? Well, when we think of, when you think about a remittance and people sending money back home to mom or something, they haven't, if they're only making $100 a day and they're spending half of that on the wiring fee, that's not cool,
Right.
right? And so when we can start to have decentralized borders for remittance payments and things like that, that's where we see a lot of traction early on in Bitcoin. That's where it was being used quite a bit was for remittance type payments. But those are the types of things where we see in DeFi. Now, if I take the next step, right? So think about this for a second. Your question is where are we going to see next? Well, DeFi is already getting hit, so that's not next. That's right now. Well, what's the next thing that's most important to you? And we touched on that earlier. And man, that's my
Yeah.
health.
Yeah.
And I'm going to be honest with you. The fact that we don't have ownership of our health data, and it belongs somewhere in some silo at the hospital, at Cerner or Epic, and I got to get them to release my records in order for me to get service. That isn't cool, because at some point in your life, having a full view of your medical history and your medical information is going to be more important to you than anything. And so I really feel like that's where we're really going to see some disruption. And that's going to be our ability to own us,
Yeah.
right, and own our medical history.
I look forward to that day. Trust me, I think that'll be great. So I warned you that I had two questions for you that I was going to throw at you.
Sure.
The second one is this: Status Go is all about action. We love to leave our listeners
Uh-huh.
with a solid, clear call to action. So, Tommy, what are one or two things our listeners should do tomorrow because they listened to our conversation today?
Hey, go out to our website, simbachain.com. Take a look at some of the things that we're doing. Go ahead and sign up for an account. It's totally free. And start mocking up what you think a blockchain can do.
Oh,
It's really that easy with our quick start tool. So you can use our step-by-step instructions. You can start building out a web-based API and just start mocking up what you think it should look like.
I love that there's a tool out there that you can go play with this and mock it up and see what it can do. That is outstanding advice. Tommy, I got to thank you so much
Yeah,
for taking the time to chat with us. I know with what you're doing, you're running in a million different directions all day long. I can only imagine. And I've enjoyed our conversation. And I love that we were already connected on LinkedIn. So now I feel like I've got an even stronger connection with you. Thank you so much, man. I appreciate it.
absolutely my pleasure, and look forward to talking to you again sometime.
To our listeners, if you have a question or want to learn more, visit intervision.com. In our show notes, we'll provide links and contact information, including a link to the tool that Tommy mentioned. This is Jeff Tunn for Tommy Cooksey. Thank you very much for listening.
You've been listening to the Status Go podcast. You can subscribe on iTunes or get more information at intervision.com. If you'd like to contribute to the conversation, find Intervision on Facebook, LinkedIn, or Twitter. Thank you for listening. Until next time.